Safety Floater is an IoT Go project for coastal tourism about blue growth. We developed the project with several constraints. They are all sensors are constantly simple, detection of false positive, movement of the floater due to rough sea, need of using waterproof sensors and casting shaped Y, solar panels in order to improve the battery life, and power consumption management. We focused on four of these that you can see from this slide. And between the main functionalities of Safety Floater, we have both detection mechanism, orientation control mechanism, and power management mechanism. The first is used to detect the boats, the second to keep the correct orientation, and the third to monitor the battery life of the buoy. Now we'll see a picture of the chassis of our prototype, and after this we'll see the inside of it with some wiring and some components, and in the end we'll see the spotter that is composed by the ultrasonic proximity sensor, the stepper motor, and a gyroscope in order to keep the correct orientation and keep the safety line in the right way.
Now we can see some images and videos of the prototype in action. In particular, here we are at the Terracinas beach. Okay, now we have this view of the Raspberry Pi camera together with the Raspberry, obviously, in the inside of this box, and this is obviously only for demonstrative purposes, because the Raspberry Pi is not connected to the LAN and also not connected to the power. Now we can see a first video where we are trying to test our prototype in an emulated environment. Here, in particular, there is the buzzer that is sounding and the correction of our stepper motor and of the spotter. Here we have the testing in the real environment at the beach, where we can see the correction of the spotter thanks to the gyroscope. In particular, the safety line is considered parallel to the beach, and here we have another video where we can see better the correction that is done by the gyroscope of the to the spotter in order for the proximity sensor to correctly detect the boats with a better probability. Obviously, the whole prototype is inside this container because, as we said from the constraints, we didn't want that all our electronic components were broken by the sea water.
We will see the sea station and the dashboard. Here we can see the Raspberry Pi screen. We start the main program, which starts detection. We can see that is connected with the Bluetooth to the Arduino. And here the first string with coordinates that is directly pushed to MQTT and then to DynamoDB if a violation is detected. We can see how data are formatted, and then there are rule that pushes the data right on DynamoDB. Then we go to the dashboard, we log in, and here we can see the table with all the violation detected. If we click on the More Info button, we can see the image related to the violation with a map with the coordinates.